Okay, here we go. Let's work on section 8.4, the slope-intercept form of a linear equation. So when we talk about linear equations, that's equations with two variables, there are three different types. We have one that's called slope-intercept form, and that equation looks like y equals mx plus b. We have standard form, and the standard form looks like ax plus by equals c. And then we have point slope form. And point slope form looks like y minus y sub 1 equals m times the quantity x minus x sub 1. And we'll go into detail of standard form and point slope, but a little bit in more detail a little bit later on in second semester. But slope-intercept, we are going to be able to pull out the slope and the y-intercept. In standard form, we pull out the x-intercept and the y-intercept. That's what we're able to find. In point slope, we are able to find, we're able to find a point and the slope. So I'll just do this. The slope is going to be the coefficient of x, the number in front of x, when the equation is isolated for y. It must be solved for y in order to pull out the slope and the y-intercept. In standard form, the x-intercept is going to be, it's a little bit more technical. It's not something you can just look at, but the x-intercept is going to equal c over y, excuse me, not c over y, sorry. I think it's c over b. And the y-intercept, oops, sorry, I'm doing it off the cuff, sorry, I'm trying to solve it. X and y, 0, sorry, c over a, and the y-intercept is going to be c over b. Sorry, that's correct. And the point in this equation for point slope is going to be, the point is going to be x sub 1, y sub 1, and the slope again is going to equal m. So in this one, the point, let's do the slope. Slope is going to be the coefficient of that, and we'll use purple. It's going to be x sub 1, y sub 1, so you have x sub 1 and y sub 1. So be careful of that because there's a negative in front of it typically, so we need the opposite of what you see. That's very technical right there, but we'll go into it, as I said, a little bit later in the school year. So the y-intercept and the slope. So what we're going to work with is slope-intercept form. But those are three very important equations that we should be able to recognize in what format that's going to be. But today we are going to only work on slope-intercept form of a linear equation. So let's start. So find the slope and y-intercept of y equals 3/5 x plus 2. So as I mentioned, when we get y isolated, typically a linear equation will be in this form, where the coefficient of x is considered the slope, and the constant, whatever is being added or subtracted, is considered the y-intercept. So let's also explain what intercepts are. We talked about this a little bit. So x-axis, y-axis, any point on the y-axis, and an intercept is where it crosses the axis. So if we're talking about the x-intercept, it's because it crosses where it intercepts the x-axis. So this line, let's make a line here, let's make another I probably didn't want to do it blue, but let's make this line. And so a line looks like this. That would be considered the x-intercept. And let's not make this blue. Let's make that red. This would be considered the, the y-intercept. This would be the y-intercept because it's where it crosses the y-axis. All right, so if we have this line, and we know that the intercepts are where this line crosses the x and the y-intercept. We know that the x value will always be 0. Will always be 0 for the y-intercept. And we know that this coordinate, we know that the y value in the x-intercept will always be 0. We don't know what the x value is. We don't know what the y value is. In the y-intercept, we know it's positive because it's to the right, but we don't know what exactly it is. So that's going to be open to depending on the line. And I'll show you what I mean by that. If we go to here and we draw a couple lines. Let's draw a couple lines. Let's draw that line. Well, let's change the color of that too. Now we need to differentiate colors. Let's do a red one. That's not a red line. Let's do a red one. This is not working very well. Can I have a red line, please? Do I have to go back to that? No, why is that not allowing me to do that? Let's have arrows. Let's change the color. Oh, it continues. Oh, okay, there you go. Ooh, that was a little frustrating there for a second. So let's just take these two. Let's just make it. Let's do that. I like that. That's good. All right, so if we look at the blue problem, if we look at the blue line and we look at its intercepts, so let's look at the x, or this is the y-intercept because it crosses the y-axis. This is where the x-intercept for the blue line is because that's where the line crosses the x-axis. So if we looked at those coordinates, this y-intercept, where it crosses the y-axis, is going to be 0, -1. The x-intercept for the blue line is going to be -3, 0. So remember what I said, all x-intercepts will have 0 for y, and all y-intercepts will have 0 for x's. Let's look at the red equation, or red line. And there's our y-intercept. Here's our x-intercept for the red line. And if we look at those coordinates, the y-intercept is going to be 0, 1, 2, 3, 4. So again, notice the y value is 0 for the y-intercept, and the x value is 0 for the y-intercept. Mr. Mack, I knew I made the mistake there. And the x-intercept is going to be, for the red point, is going to be -1, 2, 3, 4, 5, -5, 0. So for the x-intercept, y is always going to be 0. So that's something we should always be aware of. Well, where can I put that info? Let's do this. Let's move you over. All x-intercepts have y equals 0. All y-intercepts have x equals 0. And remember, if we look at this point, if we look at a point like this, right, x is 7, 6, 5, 4, 3, 2, 1, 0. When x is 0, it's on that y-axis, so that's why we know that all y-intercepts will have x value of 0. All y-intercepts will have y value of 0. So let's go back to this. So finding the slope-intercept. So the slope is always going to be the coefficient. So when we look at this equation, y equals 3/5 x plus 2, the first question we have to ask, is it in slope-intercept form? And how do we know this is in slope-intercept form? Y is isolated. Is y by itself? Yeah, y is by itself. Now we look at the coefficient of x, the number in front of the variable. So what's the coefficient of x? It's 3/5. So that tells me that the slope of that line is 3/5. What is the y-intercept? The other thing I can pull out is the y-intercept. What's being added and subtracted to the variable x? Well, I see that my y-intercept, I see that 2. So my y-intercept is 2 and my slope is 3/5. When we have equations like this, 2x plus 3y equals 6, this is not in slope-intercept form because y is not isolated. So this is actually in standard form. So what do we need to do in order to get it in slope-intercept form? We have to solve for y. That's why in the other section, we did a problem like this, 8283. We tried a number of problems where we had to isolate y. So there are two things happening to it. 2x is being added to it, and 3 is multiplying. We're always going to get rid of things being added and subtracted. That leaves you with 3y equals 2x plus 6. Now you see why I want variables first, because it needs to be in y equals mx, x coming first, then the constant. Now we have to get rid of the 3 multiplying, so we're going to divide everything by 3. That leaves you with y equals 2/3 x plus 2. Now y is isolated, so now we know that it's in slope-intercept form, so the slope is going to be the coefficient of x, which is 2/3, and the y-intercept is going to be whatever is being added and subtracted to the variable. All right, here are a couple problems for you to try, 1, 4, 7, 10, 11, and an extra. Pause the video, and when you're ready, let's go over these problems. All right, so the first equation that we have is, come on up. First equation is y equals 2x plus 1. We know that the slope, it is in slope-intercept form because y is isolated. We've got y by itself. So the slope is going to be the coefficient of x, which is 2, and the y-intercept is going to be whatever is added and subtracted. So that would be number 1. Number 4, we have y equals 2/3 x plus 3. First thing we should look at is y isolated. Yes, y is by itself. So now I can pull out the slope and the y-intercept. The slope is a coefficient of x, 2/3. The y-intercept is 3. Number 7, y equals 8 minus 2x. Is y isolated? Yes. However, notice not in, the variable is not first. So we have to rearrange that right side so my variable comes first. And when you flip it, you better make sure that that negative that's attached to the 2 is attached to the 2 when you rewrite it. And this 8 is a positive, so it better be positive when you flip it. Now we can pull out the slope, which is -2, and the y-intercept, which is 8. That was number 7. Let's look at number 10. Number 10 is a little tricky. Y equals negative x. Is it in slope-intercept form? Is y isolated? Yes. So now we look at the coefficient of x. What's the number in front of x? Well, we need to understand that this really could look like this. That helps us find what the slope is. The slope is the coefficient of x, which is -1, and then my y-intercept is 0. That's a tricky one because there's nothing being added. What's the constant in y equals negative x? It's 0. Number 11 is also tricky. Y equals -4, I think is what it is. Yep. So again, what does that look like? Well, that looks like y. There is no x, right? So it really looks like this. Y equals 0x minus 4. So the slope equals 0, and the y-intercept equals -4. Good. And the last one, also tricky, x equals 5. This is the extra one. What's that? What did I say? X equals 5? X equals 5. So this is very tricky. X equals 5. Now, this is not in slope-intercept form because it's not isolated for y. But in our head, we need to understand what does that graph look like. X equals 5. 1, 2, 3, 4, 5. So that looks like that. So what is that slope? If you pick 2 points and you ask what the rise over the run, well, you go up. Let's do it that way. You rise 3, you go up 3, but you run or go right 0. So that's 3 over 0, which equals no slope. So the slope of a vertical line is no slope. Remember, I don't want to ski that one. That would be crazy to ski. So that's no slope. The y-intercept, here's the other tricky part of this. Where does this line cross the y-axis? Here's my y-axis. Where does it cross it? It doesn't. So there's no y-intercept. So when you have one variable and that variable is x, it has no slope and it has no y-intercept. If we look at this one, y equals -4, let's look and see what that graph looks like. Where does y equal -4? 1, -1, -2, -3, -4. So that's a horizontal line. So the slope, if you pick 2 points again, what is your rise and run? You rise 0. And how much do you run? You run 2. So you go right 2. 0 over 2 is equal to 0. Hence why our slope is 0. Where does it cross the y-axis? It crosses at -4. So you'll see, even though there's only one variable in 11, it still has a slope and a y-intercept. When you have 2 variables, it absolutely has a slope and an intercept. And when it only has one variable and it's x, there's no slope and no y-intercept. So very, very technical there. Lots of information for you to take in. Use only the slope and the y-intercept to graph. So we used to use an H chart, and that was very inefficient. That was hard, and it was time consuming, and it was very, what my buzzword this year, labor intensive. You had to plug in 0, y equals -3/4 times 0 plus 6, y equals 0 plus 6, y equals 6. 1 point is 6, and you would have to do that 3 times. You'd have to do 1, blah, blah, blah. That's way too complicated. It's way too much work. Now that we know about slope-intercept form, what we can do is we can use the slope and the intercept in order to graph this. So let's erase that. So if we have the equation y equals -3/4 x plus 6. Did I forget the negative? Oh no, I had it. Good. So this is in slope-intercept form. How do we know? Because y is isolated. So I know what the slope is going to be the coefficient of x, and the y-intercept is going to equal 6. So what do we know? Well, how are we going to graph that? The way we're going to graph that is that we know that the slope from point to point is going to go down 3, right 4, or up 3, left 4. But we don't know what point to go from on that line, so we always have to graph the y-intercept first. So the y-intercept is 6. 1, 2, 3, 4, 5, 6. So I know a point now on this line. I didn't know a point until I plot one. And the easiest point to plot is an intercept. In this case, it's the y-intercept. Now I'm going to use the slope-intercept second. And if my slope is negative 3/4, that means my rise over run, rise is up, down, and run is left, right. So in slope-ese, -3, negative means down 3. And +4 means right 4. Right is always going to positive, left is negative, up is positive, down is negative. All right, so from this point, from this intercept, I'm going to go down 3, 1, 2, 3, and right 4, 1, 2, 3, 4. I make a point. Then I can use it again, down 3, 1, 2, 3, right 4, 1, 2, 3, 4. And once I have 3 points, I can connect the dots, and I've been able to graph that line. Technically, I'd like you to label those points. 0, 6, that's going to be 4, 3, and this is going to be 8, 0. Labeling is extremely important, so I know what points you are on. Just dotting them and your messy handwriting doesn't help me. So you got to list a couple of points, and you have to label them. Let's talk about that slope. That slope, negative 3/4. Remember that negative can go in the numerator, or the negative can go in the denominator. It can't go into both. It has to either be in the top or the bottom. This is if it's in the top. So if it was in the bottom, we would have done up 3, because +3 is up, and we would go left 4, because left is negative. So if we go back to this original, up 3, 1, 2, 3, left 4, 1, 2, 3, 4, you notice we're still on the line, and it still would do it. So it doesn't matter which one you choose for your slope. All right? So use only a slope y-intercept. Okay, so let's look at this. Now it's in standard form. So meaning y is not isolated. So you should solve for y. Let's put it in slope-intercept form. So I want to get y by itself. I'm going to subtract 2x, because what gets rid of a positive 2x is a negative 2x. That leaves me with negative 5y equals negative 2x plus 10. The variable x should come first on that right side. Then I'm going to divide by 5, negative 5, excuse me. Everything by negative 5. That leaves me with y equals negative 2 over negative 5x minus 2. Now this I wouldn't leave like that. I would simplify those double negatives. So my final answer would be 2/5 x minus 2. What is my slope? My slope is 2/5, and my y-intercept is negative 2. Which one am I going to plot first when I want to graph it? What am I going to plot first? Am I going to plot the slope or the y-intercept? I can't plot the slope because the slope is up to right 5. But where am I going up to from? Am I going from the origin? Am I going from this random dot here? No. That's why I can't use the slope, because I don't have a point to go up 2, right 5. So I must plot my intercept first, because once I plot the intercept, I have a point on that line. I know this line crosses the y-axis at -2. So here's my y-axis, here's -2. Now I can use my slope up 2, right 5. 1, 2, 3, 4, 5. I make a dot. Up 2, 1, 2, 3, 4, 5. If I wanted to reverse it, I would go down 2, left 5. And notice it would still be in that straight line. Still be okay, and I'd be able to represent the graph. Let's do that. And we would definitely, when graphing, we want to put arrows in order to show that there are infinite solutions, and then I want to label the points. That is 1, 2, 3, 4, 5, 5, 0. This is 0, -2, and labeling 3 is fine if you want to do this one. I think that's 1, 2, 3, 4, 5, -5, 1, 2, 3, -4. Okay, good. So when it's not in slope-intercept form, you would want to isolate for the variable y. So here are 4 problems. Give them a try. I want you to graph each one individually. Graph them on their own coordinate graph. Don't layer them up over each other. And let's try them out. Sorry. Pause the video. Do those 4 problems when you're ready. Come back and play the video. So let's do the first one. Let's take the first equation. I know that my slope is equal to -1 as a fraction, -1/1, and that means down 1 and right 1, rise over run. And my y-intercept is going to be +5. So I pull out my graph. I'm going to plot my y-intercept first. Whoops. Can I go there? There you go. My y-intercept is 5, 1, 2, 3, 4, 5. I know that point. And now I'm going to use the slope of -1, which is down 1, right 1, down 1, right 1. I connect the dots. I put arrows on my lines. I'm going to label my points 0, 5, 1, 4, 2, 3. And then I'm done. Let's clone this page. Clone it. Let's erase this. Let's do this. That was number 13. This is going to be number 16. So number 16, my slope equals 4/5, and my y-intercept equals -3. So I'm going to graph my y-intercept first. 1, -2, -3, make a point. My slope is 4/5. That's up 4. That's right 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. I've got 3 points. I'm going to connect the dots. Oh, that was pretty good. That was spot on there. Let's make sure we have our arrows on our line. This is 0, -3. When I write coordinates, I need to have them parentheses, and there should be a comma between the x value and the y value. Let's erase these dots here. And the other point is 1, 2, 3, 4, 5, 1. And my last point is 10, 1, 2, 3, 4, 5. And we would be done. Let's clone this. Good. Let's do number 19. Number 19, we have to notice that that is not in slope-intercept form. So we have to isolate for y. I'm going to get y by itself. I'm going to subtract x. That gives me y equals negative x plus 8. Let's erase this. Sorry. We'll leave you for the time being. We'll save you because we're going to need you in a second. All right, what is my slope? My slope is -1, and my y-intercept is 8. So I'm going to plot, I'm going to graph my y-intercept, which is 8, and then my slope, which is -1 over 1. -1 as a fraction is -1 over 1. 6 as a fraction is 6 over 1. 10 as a fraction is 10 over 1. So -1 as a fraction is -1 over 1. That means down 1, right 1. So down 1, right 1, down 1, right 1. And I'm going to use my, oh, that was almost perfect. Good, there's my graph. I'm going to put my arrows. I'm going to notate my coordinates, 0, 8, that is 1, 7, and 2, 6. Good. And the last one for graphing, let's clone that page. Let's erase this. Let's put that line over here for a second. This is going to be number 22. We have to do a little work prior to. We have to be able to find the slope and the y-intercept. So when we have this, we see that y is not by itself. That's negative y. So I got to get rid of the 2x. I'm going to subtract 2x. The negative y equals negative 2x minus 4. I'm either going to multiply by -1 or divide everything by -1. This gives me y. The 2 negatives here gives me positive 2x. The 2 negatives here gives me positive 4. So be aware of those double negatives. Negative divided by a negative is a positive. My slope equals 2. My y-intercept equals 4. Let's graph the y-intercept. 1, 2, 3, 4. And now let's use slope. Slope is 2. 2 as a fraction is 2 over 1. That means up 2, right 1. 1, 2, right 1. 1, 2, right 1. Oh, wow, that was bad. Let's erase that. Up 2, right 1. Up 2, right 1. Let's use our lovely through the points. Perfect. Let's draw arrows. Let's label our coordinates. 0, 4, 1, 6, 2, 8. Very nice. All right. If you have a computer or graphing calculator, you can use it to investigate the relationships amongst the graphs of equations that have the same slope but different y-intercepts. Lines in the same plane that do not intersect are parallel. So let's take a look at that while we're working on this. Safari homework. Let's go to Desmos. And if we take the equation y equals 3x, what would the y-intercept be? There is no constant being added or subtracted to x, so we know the y-intercept would be 0. Where does this line cross the y-axis? At 0. What is the slope? 3. That means it's going to go up 3, 1, 2, 3, and then right 1. Let's see if we can get better digits. There we go. Up 3, right 1. Okay? Now if I use that same equation but change its y-intercept, we see that lines with the same slope, well, let's separate it a little bit more. That gives it a little space. So they have the same slope, meaning they have the same rate of change. This is going to go up 3. 1, 2, 3, right 1. It's going to go up 3, 1, 2, 3, right 1. And if we look at the red line, it goes up 1, 2, 3, right 1. 1, 2, 3, right 1. So they dance in the same form. They're moving in the same rate of change. If I have y equals 3x minus 5, we notice that those lines are parallel. It still has the same rate of change, up 3, right 1, same slope. It just crosses the y-axis at a different place. So if we focus in a little bit, and let's turn those off, we'll see how this line will dance. 1, 2, 3, whoops, sorry. 2, 3, 4, 5. You see it moving up the y-axis. 6, 7, 8, 9, 10. So that's just moving that line on that same degree up the y-axis. Okay, so that's why it's very important. Now we can get a little crazy here and we can do different slopes. So 3x, that means it's going up 3, right 1. What if I have y equals 10x? Notice how much steeper it is because it's going up 10 before it moves its 1. This only goes up 3 and moves right 1. So anything with a steeper numerator, 10, what if we had y equals 100x? That slope, it would have to go up 100 before it goes to the right 1. You see that? And they're all going through the same location because the y-intercept for each of these is 0. If we added 1 to all of them, it would just make the y-intercepts are all 1. Okay? Now, what if my numerator in 3, 10, and 100, the numerator was bigger than the denominator, 3 over 1, 10 over 1, 100 over 1. What if I flip it? What if I have the denominator bigger? Let's do 1 over 3x. And what if I have 1 or y equals 1 over 10x? And what if I have y equals 1 over 100x? So now, if we look at this, if we look at the blue, let's turn those off. If we look at this, we're going to go, sorry, that's way too small. There we go. We're going up 1, right 3. And then we go up 1, right 3. We go up 1, right 3. If I do it 1/10, that means we're going up 1, but now we're going out 10 places. So we're going to go way, way out there. And then we're going to go up 1, and then we're going to go out another 10. And if we do 1 over 100, that means we go up 1 and then out 100. So that's going to be super flat. So notice the difference. As that denominator gets bigger, it's going to be even more flat of a line. That slope is going to get flatter and flatter. All right, so very important for us to be able to fiddle around with Desmos and see how the coefficient of x, how the slope, and how the y-intercept change the peculiarities about lines. And I'll leave that page. So we know that when lines, oh gosh, hold my microphone. So we know that when lines with the same slope will always be parallel. So if we look at this, y equals 2/3 x and y equals 2/3 x minus 10, what do we know about these two lines? We know that they are parallel. What's the slope? The slope is 2/3. What's the y-intercept? The y-intercept is 0. What's the slope of this line? The slope is 2/3. What's the y-intercept? Is -10. But because the slopes are the same, we know that these two lines are going to be parallel. So if we can find the slopes, we will know whether they are parallel. And if they're parallel, they won't intersect. Show that the lines whose equation 2x plus y equals 8 and 2x plus y equals 6 are parallel. Well, they're not in slope-intercept form. That's the first thing that I should notice. So I can't automatically find out what the slope is in this format. So in order to find the slope, I need to solve for y. So I'm going to solve for y in each of these equations. I'm going to subtract 2x. What is going on with my pen? Subtract 2x. That leaves me with y equals negative 2x plus 8. Remember, the variable comes first. And now I have found my y-intercept. Or excuse me, my slope. My slope is negative 2. Let's solve for y on this one. Negative 2x minus 2x. We get y equals negative 2x plus 6. What is my slope? My slope is negative 2. So we know that these two lines are parallel. Good. So let's try these two. Pause the video when you are ready. Unpause the video or play the video again, and you'll hear the explanation for whether these lines are parallel or not. All right, so the first thing we want to do is we want to isolate. We want to take each equation and we want to isolate for y. We're going to get y by itself. Now we see the importance of knowing how to move across the equations, how to move variables and other items when we have an equation. Divide by negative 3, divide by negative 3, divide by negative 3. We get y equals positive 2/3 x minus 7/3. So we see that the slope of this line is 2/3. We also see that two negatives make a positive, and it must be simplified. You always got to simplify your work. I didn't want to do that. Let's do that. Good. So that's the first equation. Now let's do the other equation. The other equation is negative 2x plus 3y equals 4. Remember, we're trying to isolate y. What's going to get rid of a negative 2x is a positive 2x. You get 3y equals 2x plus 4. We're going to divide by 3, divide by 3, divide by 3. Y equals 2/3 x plus 4/3. What's the y-intercept? The coefficient of x. So these two lines are parallel because they both have slopes of 2/3. So we know that they are parallel lines. Are they the same lines? No, because they have different intercepts. Since they have different intercepts, they are different lines, but they are parallel. They will never intersect. Let's clone this page. Let's, can I erase the ink? Let's erase ink. Clear ink from page. Yes, technology, baby. All right, let's take the first equation. 4x minus y equals 1. We are putting it in slope-intercept form. So we're going to subtract 4x. That leaves me with negative y equals negative 4x plus 1. Let's divide by negative 1, divide by negative 1, divide by negative 1. Y equals positive 4x. You saw those double negatives again. Minus 1. A positive 1 divided by negative 1 leaves us with negative 1. So my slope is going to be 4. Now we have our other equation, negative 8x plus 2y equals 2. We're isolating, getting y by itself. We're going to add 8x. We get 2y equals 8x plus 2. We're going to divide by 2, divide by 2, divide by 2. And that leaves me with y equals 4x plus 1. We see that my slope is 4. And really important, we see that the intercepts are different. If the intercepts are the same, they wouldn't be parallel because they'd be the same line. So parallel lines cannot be the same line. They have to be different lines and not intersect. So these are parallel because they have the same slope but different intercepts. Same slope, different intercepts. All right, that was a lot of work. Hopefully that helped you. Good luck with the homework. That was a good lesson.